Hello students, welcome to the Classroom Point YouTube channel. In this session, let's go for another question of the which is related to the relative layering of vapor pressure as well as the Raoults law. The given question is calculate the vapor pressure of an aqueous solution, 1 molal glucose solution at 100 degrees centigrade. So here 100 degrees centigrade. They clearly mentioned that the solution is an aqueous solution. Aqueous solution means solvent must be the water. So whatever the solvent is, that is the water, and everything is they are measuring at 100 degrees centigrade. That to 1 mole of glucose solution. Now first of all, let us try to write down the given data. Molality of the given solution is 1 m. Vapor pressure of pure solvent they did not give, but they said aqueous solution at 100 degrees centigrade. Water boils at 100 degrees centigrade only. So boiling point of water, here it is, boiling point of water is equals to 100 degrees centigrade. What does it mean by boiling point? It is the temperature at which the vapor pressure of any solution or liquid becomes equals to atmospheric pressure. We know that atmospheric pressure is 1 atmospheric pressure, that is equals to 760 millimeters of Hg, mercury. Means indirectly they had given the vapor pressure of the pure solvent in the form of the boiling point of the water. So directly we can take that value from this one, that is 760 millimeters of mercury. Now our duty is to calculate the vapor pressure of a solution, that is glucose solution. We know that relation between the molality and the relative lowering of vapor pressure formula is P0 minus Ps divided by P0 equals to molality divided by 1000 into molecular mass of solvent, molecular weight of solvent. Solvent is water here because aqueous solution they said. So molecular mass of solvent means that is equal to 18 gram per mole. So let us write down here molecular weight of solvent is equals to 18 gram per mole. So let us try to simplify this form. This can be written as 1 minus Ps by P0 equals to m divided by 1000 into molecular weight of solvent. I'll take it as 1. Okay. Now let us try to substitute everything. 1 minus Ps value is given now. Ps value is to be calculated divided by P0 value is 760 millimeters of mercury. So 760 millimeters of mercury, that equals to molality value is only 1. So 1.0 small m divided by 1000 into molecular weight of the solvent is 18 grams per mole. Now let us try to rearrange everything over here. So we get it in this form. It can be written. So you bring everything of this particular part Ps by 760 millimeters of Hg to the right hand side, it becomes plus value, and the whole value becomes the minus of this one. Okay. So let us try to solve that. So now it is 1 minus 18 divided by 1000 is equals to vapor pressure of solvent solution divided by 760 millimeters of mercury. 760 millimeters of mercury. Now we can write it as a vapor pressure of solution is equals to, send 760 that side, So 760 into 1 minus this value is, because 1000 is in denominator, no? So it becomes 0.018. So now vapor pressure of the solution becomes equals to PS value. PS is equals to 760 into 0.982. Now vapor pressure of the solution is equals to 746.32 millimeters of mercury. Now let us solve another question of the same concept. The given question is calculate the vapor pressure of an aqueous solution which contains 5 mass percent of urea. 5 mass percent means mass by mass percentage, that we will discuss in the solution. The vapor pressure of pure water solvent is given, that is 23.5 millimeters of mercury. The molar mass of urea is 60 grams per mole. First of all, as usually, let us try to write down the given data so that we will get an idea. Given data is 5 mass percentage of urea, that means 5 grams of urea is present in the 100 grams of solution. This is the total mass of the solution, but mass of the solution is equals to mass of the solute plus mass of the solvent. So that is the reason why, hence mass of the urea, that is solute, equals to 5 grams, and mass of the solvent is the mass of the solution minus solute. So 100 grams minus 5 grams, we got 95 grams. Afterwards, vapor pressure of pure solvent, that is P naught, equals 23.5 millimeters of mercury mentioned over here in the question. Molar mass of urea solute 60 grams per mole and molar mass of water 18 grams per mole. Now, as per the relative lowering of vapor pressure or Raoults law, we can write down the formula as P naught minus PS divided by P naught is equals to weight of the solute. Solute is urea here, so I will take it as U, divided by molecular weight of the solute U into molecular mass of the solvent. Solvent is water. Molecular mass of the solvent divided by mass of the solvent, weight of the solvent, that is H2O. So let's try to write down this, simplify this form as 1 minus PS by P naught is equals to weight of solute. Weight of solute is how much? That is mass of the solute 5 grams. So it is 5 grams divided by molecular weight of the solute, that is 60 grams per mole, urea. 60 grams per mole into molecular mass of the water, it is 18 grams per mole divided by mass of the water, here we have written, that is 95 grams. So now let's try to write down 1 minus PS, which is the vapor pressure of the solution, divided by solvent vapor pressure is 3.5 millimeters of mercury. This is equals to, so after solving all this particular form, we shall get value of approximately or around 0.01578. 1578. So now let us rearrange everything. We can write this particular form as PS is equals to 23.5 of millimeters of mercury. Units I am not writing over here. 1 minus 0.01578. So we will continue here the remaining part. PS is equals to 23.5 into this value, 1 minus 0.01578 value is 0.98 422. So by multiplying all these, we will get the PS is equals to 23.129 millimeters of mercury. That is the vapor pressure of the solution. So now let us see another question. The given question is the vapor pressure of pure benzene at 50 degrees centigrade is 268 millimeters of mercury. How many moles of non-volatile solute? So we need to calculate only moles, not the weight or molecular weight, anything. So how many moles of non-volatile solute per mole, each mole? So let us take the number of moles of benzene as 1. Per mole of benzene are required to prepare a solution of benzene having a vapor pressure of 160 millimeters of mercury at the same temperature, 50 degrees centigrade. Now let us write down the given data. And the vapor pressure of pure benzene is given 268 millimeters of mercury. Number of moles of benzene, since they said per mole of the benzene, let us take it as 1 mole. Vapor pressure of the solution, that is 160 millimeters of mercury. Number of moles of the solute is to be calculated. So now let us see each one by one. Here vapor pressure of benzene pure value, so that it is always equals to P naught. And this is a solution, so it is equals to PS. So now let us try to write down the formula, Raoults law formula. According to Raoults law, P naught minus PS by P naught is equals to mole fraction of the solute. So for dilute solutions, let us see here, it can be expanded as P naught minus PS by P naught equals to mole fraction of solute, means number of moles of solute by number of moles of the solvent plus number of moles of the solute. But we know that for dilute solutions, number of moles of the solute is very less. Number of moles of solute is far less than the number of moles of the solvent. So N2 from the denominator can be neglected. So final formula becomes P naught minus PS by P naught is equals to number of moles of the solute by number of moles of the solvent. So now let us try to substitute all the given data in this formula. P naught value is 268 millimeters of Hg. So this is equals to 268. I am not taking the units. 260 because relative ratio of the pressures only to get cancels. 268 millimeters of Hg minus PS 160 millimeters of Hg divided by again 268 millimeters of mercury equals to number of moles of the solute is to be calculated, that is N2. Number of moles of the solvent, anyhow it is 1 mole only. So by solving all of this we get the 0.675. This is the answer of this question. Now let us solve another question. The given question is calculate the vapor pressure lowering caused by the addition of 68.4 grams of sucrose, its molecular mass also mentioned in the bracket, as 342 grams per mole to 500 grams of water. If the vapor pressure of pure water at 25 degrees centigrade, this is 25 degrees centigrade, is 20 millimeters of Hg. Let's see what the procedure is given. First of all, vapor pressure of solvent, pure water, they mentioned here, that is 20 millimeters of mercury. 20 millimeters of mercury. Lowering of vapor pressure. What does it mean by lowering of vapor pressure? It is nothing but the difference between the pure solvent vapor pressure to the solution vapor pressure. That is called as lowering of vapor pressure. Or simply, since it is the difference between the two pressures, we can call it as a delta P. Okay. So that has to be calculated. Molecular mass of the sucrose solute 68. Mass of the solute is given 68.4 grams. Molecular mass of the solute is 342 grams per mole, and the mass of the solvent water mentioned here, that is 500 grams of the water, and its molecular mass no need to go, that is 18 grams per mole. Now let us complete the calculation. We know the formula according to the Raoults law. P0 minus Ps divided by P0 is equals to mole fraction of the solute. That means number of moles of the solute divided by total number of moles of the solvent plus number of moles of the solute. And this has to be calculated. P0 minus Ps, they are asking us to calculate here. So now it becomes delta P divided by P0 is equals to number of moles of solute divided by number of moles of the solvent plus number of moles of the solute. Since it has to be calculated, these are also to be calculated because their respective values are given, but not in the form of the number of moles, but in the form of the weight and molecular mass is given. So we need to calculate these two values also. So let's try to calculate the number of moles of this solute. What is the solute? Here the solute is sucrose. Formula is number of moles of solute equals to weight of solute by molecular weight of the solute. What is the weight given here? 68.4 grams divided by 342 grams per mole. So now the value, approximate value, is equals to 0.20 moles. This grams get cancelled, this is moles only. And number of moles of the solvent N1 is equals to weight of the solvent divided by its molecular mass of the solvent. What is the weight of the solvent mentioned? 500 grams. This is 500 grams divided by its molecular mass is 18 grams per mole. So this value is approximately equals to 27.78 moles. Okay. Now P0 value anyhow given. Let us try to substitute all these given data in this particular formula. So we get the formula becomes now equals to delta P because we'll send the P0 this side and substitute all these. So it becomes number of moles of the solute. Here number of moles of the solute is given. So number of moles of the solute value is 0.20. Directly I am trying to substitute, or else I will take once again the formula and finally will substitute it here. N1 plus N2 into P0. Now delta P is equals to, let us substitute all these values. N2 value is 0.20 divided by 0. This value I am writing here, 0.20 plus this value I am writing over here, 27.78 into P0 value mentioned here as 20 millimeters of mercury. So 20 millimeters of mercury. Since it is a fraction, moles cancels out. So finally change of pressure, that is lowering of vapor pressure, units will be millimeters of mercury. And after solving all of these, we shall get a value that is approximately equals to 0.142 millimeters of mercury. This much of vapor pressure is decreased by the addition of 68.4 grams of sucrose to the 500 grams of water at 25 degrees centigrade. So the final answer, we got it. I hope you like this video. If you like, please subscribe the channel, and do not forget to click on the bell icon So in future, whatever the questions or solutions are, these are simple questions which I am solving now. In future, I may give the good questions. I am trying already. They are in the line. But initially, I am giving only simple questions. So once the tricks and the questions are coming, that may alert you through email once you click the bell icon. So that is the reason why do not forget to subscribe and do not forget to click on the bell icon. Thank you.